Hello, this is Dr. Cole Woolley, and this lesson is called Understanding MS Principles. This is all about using the GCMS in order to differentiate between Oman frankincense and Somalia frankincense. So let's get into understanding the MS portion of GCMS. First of all, this is the GCMS instrument, and the MS stands for mass spectrometer. Mass refers to the molecules themselves. They have different sizes or masses, and then spectrometer means being able to separate those by mass. Now, the mass spectrometer is the tail end of the instrument, these two portions, and we'll talk about how they work. Now, the goal of the GCMS is first to separate the molecules that are found in the essential oil. And the MS portion, its job is to give each component a name. In this example, I've given the name of linalool and linalyl acetate to the two very large components. That's what a mass spectrometer does. But the mass spectrometer is still needed to identify all the rest of these components, to give them a name so that we can create a report what components and what percent of each one of these components is in the lavender essential oil. So let's look at the process of the mass spectrometer. First of all, the separated molecules from the GC enter the MS. And then in the mass spectrometer, there's a high energy that takes the separated molecules one by one and breaks them into fragments. Now remember, each of the molecules has a different structure. So when they break up, they break into different kind of fragments. And these fragments are collected every second or every fraction of a second. The collection of these fragments helps to create the total ion chromatogram and the mass spectrum. And that's the display from the mass spectrometer. This is what a mass spectrometer display looks like. Now, doesn't this look like you might be sitting in the cockpit of a jet airplane and you're looking at something and saying, I don't know which button to push? Well, a good analytical chemist, somebody trained in the operation of GCMS, can take the information that comes from a GCMS separation and be able to use it to identify each one of the components. So let's look at the different mass spectrum, or the fragments that come from different molecules. Here's an example of the mass fragments or mass spectrum from alpha pinene. These are the smaller fragments, the medium-sized fragments, and the heavy fragments. This fragment right here, mass 93, has the highest intensity. The fragment pattern for alpha pinene is the same in just about every GCMS instrument. So the mass spectrometer, what it does is every second it collects the fragments, whether the fragments are small, medium, or large, and then it puts them together every second. These molecules can range from 40 all the way up to 300 plus mass units. This collection is known as the mass spectrum. We talk about the mass spectrometer as the instrument. The collection of the fragments is called the mass spectrum. Again, let's look at a mass spectrum for beta pinene. The fragmentation pattern is a little bit different. Let's look at the fragmentation pattern or mass spectrum for sabinine. It's also different. Again, the different chemical structure of these molecules creates a different fragmentation patterns. Now let's look at some fragmentation patterns for a number of essential oil components to determine if they look alike or if they are completely different. Well, let's look at the fragmentation pattern for alpha pinene on top. Compare it with sabinine, myrcene, 3-carine, ocimene, beta-pinene, and alpha-philandrine. Do any of them look alike? Well, they look somewhat similar. They might have the same masses like this one. Seems to be very common. But they're different because the chemical structure of each of the molecules is very unique from each other. So when the molecules are fragmented by high energy in the mass spectrometer, and collected, then it forms these different patterns. These different patterns are going to help in the mass spectrometer software to be able to give a name to each of the separated components. The mass spectrum is a display of mass size in the x-axis and mass abundance in the y-axis. As I said before, the mass spectrum that I get from my GCMS is very similar for alpha-pinene in the mass spectrum of every GCMS instrument throughout the world. This helps because I can take a reference library of alpha-pinene mass spectrum and compare it with my sample of lavender essential oil or frankincense essential oil or any essential oil and be able to identify alpha-pinene in my essential oil using this reference library. So here's an example again of saponine. Here's the intensity versus mass. That's the mass spectrum. Now we take that digital information and it's put into a library. These mass spectral libraries are very important to help me identify components in the essential oil. And these mass spectral reference libraries can contain 200,000 to 1,000,000 different mass spectra. The library lists the component name and the mass spectrum. All I have to do is compare my mass spectrum with the mass spectral library, and if they match, that gives me the name of the component. Here's another example of the mass spectral matching. So I can compare my essential oil component with the possible best match in the reference library. So this software is very important to help me identify the essential oil component. This software will search all the mass spectra in its reference library and say, these are the 10 mass spectra that match best to my mass spectrum. And then it'll say, these are the names of the components. And I choose from those. I take the best match and I give that separated component a name. Again, here's another example of matching mass spectra so that I can name each one of the separated components. In addition, I also use retention index values. They're like street addresses for each one of these molecules. They should come out in a certain order. And so I use these to confirm the name. And when I have the GCMS mass spectral match and the match for retention index, I'm 99.9% certain of the name of the separated component. For the automated GCMS instrument, the mass spectrometer is 90 to 95% accurate in naming molecules. The rest of the inaccuracy requires me, as the trained analytical chemist, to be able to determine. Now, again, the job of the mass spectrometer, the MS portion of GCMS, is to provide names for the separated components from the GC. So the GC does the separation, the MS provides the names. So now we have a complete understanding of all the components in lavender, how abundant they are, and each one of the names, and then we put them into a GCMS report that identifies this as lavender essential oil. So if somebody asks you, what is the job of the MS in the GCMS instrument? You can say the MS, or mass spectrometer, is a device that helps put a name with each separated essential oil component. That's the job of the mass spectrometer.